So welcome to First Take Math with Brian Thomas. This evening we're going to work with factoring trinomials. The strategy we want to try to impose on this is called the MAMA strategy or MAMA strategy. In other words, there's some multiplying and adding thinking. The M stands for multiply, the A stands for add. So we kind of multiply add thinking is what the strategy is going to be about. First off, let's just review a little bit factors of 12. So if I use a rectangle model, what we're trying to do is look for the edges that can multiply to give you a 12. And notice that there's some possibilities here. To multiply to get a 12, I could do like a 1 and a 12. 1 times 12 is 12, so those could have been the edges. But that's not the only way to get a 12. Don't forget we could have used 2 times 6 could have also been the edges. Or we could have also had a 3 and a 4. So 3 could have been here, 4 here. So there are various factors here for these edges. So I could have had a 1 and a 12, a 2 and a 6, or a 3 and a 4. So again, the 12 is kind of the area of the box. The factors are the edges. So when I look at this problem right here, the x plus 4 and the x plus 3 are called the factors. Those are going to be the edges of the rectangle. So I'm going to have like an x and a 4 here, and an x and a 3 on this edge. And then the product would be x squared, 3x, 4x, and then a 12. Because x times x is x squared, 3 times x is 3x, 4 times x is 4x, and 4 times 3 is 12. And remember, these two guys kind of get added together to get the 7. It's going to actually be a 7x there. So this actually becomes the x squared plus the 7x plus the 12. And the edges again were the x plus the 4 was this edge, the x plus 3 was this edge. So the factors are the edges. The trinomial is actually going to be this interior part. Notice though, what's important is the x squared is this upper left-hand corner. The 12 is the bottom right-hand corner. The 7x is created by this 4x and this 3x. So we're going to use some of this thinking here to factor a trinomial. So let's look at this problem right here, x squared plus 5x plus 6. We want to factor this. Well, to factor this, what we're looking for are the two edges. We're looking for this edge and looking for this edge. So right now, we know that this is going to be partitioned into 4 regions. The x squared part is the part that forms the upper left-hand corner. The 6 goes down in this corner. So we know x and x go here. But what makes a 6 are some choices. I could do like 1 and a 6 to get a 6, or I could have a 2 and a 3. And this is where we impose the MAMA strategy. We want to multiply add. So if we multiply and add, we focus on the 6 in this thinking. What we're asking ourselves are, what are the ways to multiply to get a 6? Well, we know 1 times 6 is 6. Does 2 go into 6? Yeah, 2 times 3 is 6. And 3 goes into 6, so that repeats. So those are our pairings. Now what we're trying to do is figure out which one of these pairs adds up to which one of these pairs will add up to my 5, because I need this 5x here. So if we look at this, does 1 plus 6 give me 5? It looks like that's a 7. But 2 plus 3 does indeed give me 5. So when you can multiply two numbers and add those same numbers to get the 6, and we also were looking for that 5, that passes our test. So you know that 2 can go here, and that 3 can go here, and it should complete our model. 3 times x is 3x, 2 times x is 2x, and those do come together to form our 5x. So these edges become our factorization. So I have an x and a 2, x plus 2, and then an x and a 3, so x plus 3. And that would be factoring our trinomial. So we changed it into a multiplication problem. as two factors, if you will. Let's look at this next example. X squared, negative 7x, and a 10. To factor this, we're going to use the rectangular model. So again, we're going to partition this off into 4 sections. What we've learned is the x squared is going to go up in this upper left-hand corner. This positive 10 is going to go down in this bottom right-hand corner. So we know the only way to get an x squared is x times x. But there are some choices to get a 10. I can do a 1 and a 10 and a 2 and a 5. So what we do is we impose momma on this. We want to multiply and we want to add to see how this plays out. So we want to multiply to get a 10, but we want to add to get this negative 7. So that negative 7 is the part that we have to come up with addition. So we start again with 10, looking for some factors of 10. So 1 times 10 is 10. 2 times 5 is 10. 3 doesn't go to 10. 4 doesn't go to 10. 5 does go to 10, so that tells me I can stop. What we pick up on though is we need a negative 7. Well, don't forget that you could be multiplying a negative times a negative to get a positive. And a negative would add up to be a negative. So if we look at this, negative 1 times negative 10 does still give me 10. Negative 2 times negative 5 still gives me 10. But if you notice, this guy right here will add up to give me a negative 7. So negative 2 and a negative 5 does give me a negative 7. It passed our 2 tests. So negative 2 and negative 5 are our winners. They multiply to give me a 10, and they add to give me my negative 7. So those are the 2 numbers that help me build my edges. So this negative 2 builds one edge, this negative 5 builds the other edge, and these edges become my factorization. So I have then x minus 5 times the quantity x minus 2. And it really doesn't matter which way you put these edges. You can put x minus 2 here and x minus 5 here. It still is going to give me the same result. So if I plan this out, negative 5x going here, negative 2x going here, that does complete my answer, x squared minus 7x plus 10. So again, this is what we call a factorization because I changed this into a multiplication problem. So what we'll be looking at are some problems that kind of look like this. So we have this ax squared plus bx plus c form, but we're making this number here a 1. So right now we're going to focus on expressions that look like this, x squared plus bx plus c. So notice how this is just x squared, then you have some number in front of the x, and then some constant, which we call c. So let's see if we can build on that with the next lesson. Stay tuned.